Namaste. I am Dr. B. Krishna Reddy, Principal Samala Krishna Agricultural Polytechnic College, Tangailavaripalli, near Mudivedu, Tamballapalli Mandal, Chittoor district. So today's lecture number 15, unit number 8, deals with various types of fuels. That is, fuel, its definition, classification of fuels, characteristics of good fuels, etc. So this lecture is very important for diploma in agriculture engineering students because the fuel is very important item in dealing with the agricultural production, or for the basic agriculture engineering students also fuels are very important because without fuel no machine will run, and therefore understanding the fuel and their properties to know how these can be put to best possible uses in a given situation. Now let us see what from all these angles. Introduction. Fuel is a combustible substance containing carbon as main constituent, which on proper burning gives large amount of heat, which can be used economically for domestic and industrial purposes. So before going into details of the fuels, the first we should understand what exactly fuel means. In other words, definition of a fuel. One is supposed to know. So fuel is a combustible substance, that is, which will burn, and it contains carbon as a main constituent. In addition to so many components, all fuels will have a major portion of it in the form of carbon, which on proper burning, when it is subjected to burning, it gives large amounts of heat, which can be used economically for domestic and industrial purpose. This heat which is generated will be used for not only domestic purposes but also for industrial purposes. So covering all these aspects of fuel, students are expected to write the definition of the fuel. Okay, just once again we'll repeat. Fuel is a combustible substance which contains carbon as a main constituent, which on proper burning give large amount of heat, which can be used economically for domestic and industrial purposes. So examples of fuel are wood, charcoal, coal, kerosene, petrol, diesel, producer diesel gas, oil, gas, etc. are some of the fuels. Then the basic process how the fuel works we'll see in the following simplistic form of equation. Fuel plus O2, that is any fuel, need the presence of oxygen to burn. So actually fuel will have more heat energy content. In the fuel, there will be heat energy content will be high. Then after burning, there will be end product maybe in the form of ash, something will left out. But our main product or the main thing that is generated out of it is the heat. So after releasing the heat, the products which we obtain will naturally contain lesser heat energy content in them. Okay. Then the primary or main source of fuels are coals and petroleum oils, the amount of which are dwindling day by day. So what are the sources of these fuels? The main source of fuels, or otherwise known as primary source of fuels, which the present day generations are using, is comes from coals and petroleum oils. Either it will have an origin from coals, various type of coals, or it will have an origin from petroleum products, the amount of which are dwindling day by day. These coal and petroleum products are non-renewable, and therefore they are being utilized day by day, and therefore their quantity availability is reducing drastically. These are stored fuels available in Earth's crust and are generally called fossil fuels. Either coal or the petroleum products are in fact stored fuels which are available in the Earth's crust, that is underground, which are generally called as fossil fuels. These are called as fossil fuels. Why? Because the plant or animal dead bodies which are buried deep in the earth's surface thousands of years back, subjected to very high pressure and temperatures, will become fossilized, and out of that, because of the anaerobic reactions that happened underneath the earth, they got converted into fuels. Either it may be a coal or it may be a petroleum products. So that is why these are called fossil fuels. Classification of fuels. The fossil fuels have been classified as natural or primary fuels which are found in nature, such as wood, peat, coal, petroleum, natural gas, etc. In the natural or primary fuels which are found in nature, they are wood. So that is everybody's knowledge. The wood which we get from the trees after drying will be used as a fuel wood. So wood is also a type of fuel. Then peat. Peat is a one type of low quality coal-like material which is brown in color and which is available in certain parts of our country, especially in the northeast states, in the form of bogs or peatlands, where this will be excavated, and it is something like earth material which will be in brown color. It will be dried and used as a fuel. These lands from where this peat is collected is called peatlands or the peat bogs. Then coal. It is dark brown or black colored material which will be excavated from the deeper layers of the earth and which will be used as a fuel. Petroleum and natural gas. These are also called fossil fuels. These are present beneath the earth's surface, even in sea areas at a very high depth. These materials are available. These, as already explained, are the products of fossilized materials present in the underneath the earth. Then the artificial or secondary fuels. These are the fuels which are prepared from the primary fuels. So the fuels which are prepared from primary fuels is called secondary fuels or the artificial fuels. For example, charcoal. It is produced by way of burning wood under anaerobic conditions. You will get charcoal. Coke, kerosene oil, diesel oil, petrol, coal gas, oil gas, producer gases, blast furnace gases. All these are secondary because these are made from the primary sources. So here we can see one new terminal, that is producer gas. What is a producer gas? It is a low grade fuel gas consisting of large nitroxy and carbon nitrogen, large amounts of nitrogen and carbon monoxide formed by passing over air and steam through red hot carbon. So this is the process how the producer gas will be produced. Then the classification of various fuels is given in the chart form. Students need to go through it and study it well. First, fuels. Out of fuels, chemical based fuels, you can say it a chemical fuels. In that, primary or natural fuels, secondary are derived fuels, or they can also called as artificial fuels. In that, aggregations. What are the different type of aggregations? We'll see. Under primary or natural fuels, solid wood. Sorry, these are in the form of solids. Examples are wood, peat, lignite, coal, and dung. These are the solid form of natural fuels. Then liquid form, it is a crude oil. Gaseous form, natural gases. Then secondary or derived or artificial fuels are, they are also in three forms. Either it may be solid form, liquid form, or gaseous form. Example of solid forms are coke, charcoal, petroleum, and briquette. Liquid form are kerosene, diesel, petrol, synthetic gasoline, and LPG. That is liquid petroleum gas. Gaseous forms are coal gas, water gas. So water gas consists of carbon monoxide and hydrogen, made by passing steam over in a uh, in a candescent coke. When you pass, sorry, this water gas consisting of carbon monoxide and hydrogen. This is made by passing steam over the candescent coke. When we pass steam, that is water vapor, over the candescent coke, over the coke, then we will get the what is called as a water gas. Okay. Then oil gas, then biogas. This is nothing but when the decomposition of organic matter like cow dung or agricultural waste is subjected to anaerobic reactions, then a gas will be produced called biogas. This is mostly used for domestic purposes. Then blast furnace gas, coke oven gas. These are the gaseous forms of artificial fuels or secondary fuels which are produced from the primary fuels. Then calorific value. Calorific value of a fuel is the total quantity of heat liberated when a unit mass or volume of the fuel is burned completely. Calorific value means it is the units or it is the quantity of heat that is liberated when a unit mass or volume of a fuel is burned completely. Unit of heat, that is calorie, is the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. అంటే 1 గ్రాము వాటర్ని 15 డిగ్రీల సెంటిగ్రేడ్ ఉన్నటువంటి వాటర్ని 16 డిగ్రీల సెంటిగ్రేడ్ పెంచడానికి ఎంత టెంపరేచర్ అయితే కావాలనో అంటే ఎంత హీట్ అయితే కావాలనో దాన్ని క్యాలరీ అంటారు. ఒక క్యాలరీ అంటే అర్థం ఏంటంటే 1 గ్రాము వాటర్ 15 డిగ్రీలు ఉన్నప్పుడు దాన్ని తీసుకొని వేడి చేస్తే హీట్ పెడితే ఎప్పటికైతే 16 డిగ్రీల సెంటిగ్రేడ్కి వెళ్తుందో ఆ కావాల్సినటువంటి హీట్ నే 1 క్యాలరీ అంటారు. ఓకేనా? సో ఇట్ ఈస్ ఇంపార్టెంట్ టు నోట్ డౌన్ అండ్ రిమెంబర్ what is the calorific value of a fuel and what is the definition of a calorie also. Then characteristics of a good fuel. So to be a good quality fuel, what are the basic characters that need to be present in that fuel? Number one is high calorific value. A fuel should possess high calorific value since the amount of heat liberated and temperature attained thereby depends upon the calorific value of the fuel. That means unless given fuel is having high calorific value, we will not get required high temperatures or liberate higher amount of heat when a given quantity of the fuel is burned. So naturally it is desirable to have a fuel with higher calorific value than a low calorific value. Suppose if the calorific value is less means then to get a given quantity of heat or to raise to a certain level of temperature, we need to burn more quantity of the such fuel materials. So if it is having high calorific value, for the same heat or temperature, we need to burn only less quantity. So what is the desirable character here? The fuel which is having high calorific value is required. Then second desirable character is moderate ignition temperature. So what is the ignition temperature is? It is the lowest temperature to which the fuel must be preheated so that it starts burning smoothly. So it is something like an ignition point. It is the low temperature at which the fuel starts igniting. Okay. Low ignition temperature is dangerous for storage and transportation of the fuel since it can cause fire hazards. So here the fuel, if it has low ignition temperature means even at lower levels of temperature, say suppose at 20 or 25 degrees, if ignition point is like that, when such fuels are either stored or being transported, there is a very chance that this fuel is subjected to such temperatures which automatically ignites the fuel and may lead to fire accidents. So the good quality fuel is one which should not have low ignition temperature. On the other hand, if such fuels have got high ignition temperature, what does it mean? To just start ignited or to start burning, we need to have a very high temperatures, which will be once again a disadvantage because to ignite or to burn the fuel, we need to use lot of temperature and heat, which is once again a loss. So the ideal fuel is one which have neither too low ignition nor too high ignition. Therefore, it should be having a moderate ignition temperature. Okay. Then coming to the third property which is desirable for any fuel is low moisture content. The moisture content of the fuel reduces the heating value and involves in a loss of money because it is paid for at the same rate as the fuel. Hence, the fuel should have a low moisture content. Imagine that a fuel is having high moisture. So, the moisture, since a fuel is purchased either on weight basis or volume basis, when white moisture is present in the fuel, naturally it adds up to the weight of the fuel, which means we are purchasing the moisture also at the rate of the fuel, which is financially or economically not a good proposal. And in other words, even to lose that moisture, lot of heat is needed. So that is once again a loss. So as far as possible, the fuel should have low moisture content. Okay. Then fourth property, low non-combustible matter content. Like this, like water content, there may be other components which are non-combustible in nature other than water also that are present in the fuels. If such non-combustible materials are there, like water, here also one need to waste lot of heat to eliminate them. In addition to purchasing these unwanted materials at the cost of the fuel. Okay. Then moderate velocity of combustion. If the rate of combustion is low, then the required high temperatures may not be possible because a part of the heat liberated may get radiated instead of raising the temperature. On the other hand, too high combustion rates are also not required. What is the combustion velocity? That is speed with which the fuel will get completely burned out and releases maximum possible heat is its combustion velocity. If it is very low, then by combusting such materials, the required high temperatures cannot be achieved. Otherwise, if the velocity of combustion is too high, then also we will get the heat or temperature in over a very short period, which may not be a desirable one for the required purposes in industries. So, the good fuel should have moderate velocity of combustion. Okay. Then sixth one, products of combustion should not be harmful. So after burning the fuel, there would be some substances left over. Fuel and burning should not give out objectionable or harmful gases or substances. In other words, the gaseous products of combustion should not pollute the atmosphere. So as we know very well that whenever fuel materials are burned in the atmosphere, certain gases like carbon dioxide, carbon monoxide, sulfur dioxide, hydrogen sulfide, and phosphate like substances are produced. Out of these, this carbon monoxide, sulfur dioxide, and hydrogen sulfide, phosphates, etc., these are very harmful for animals and the men. So, as far as possible, the given fuel should not produce this type of harmful gases when they are combusted or when they are burned. Then, low cost. A good fuel should be readily available in bulk at a cheap rate. It is very common sense point. Nobody is expected to purchase the fuel at a higher cost because it may not be viable either for domestic purpose or for any industrial purpose. So an ideal fuel should be cheap and at the same time it should be available in abundantly. So suppose if it is cheap, not available, there will not be any use. So cost wise it should be low and availability also should be there. Eighth point, easy to transport. Fuel must be easy to handle, store and transport at a low cost. Solid and liquid fuels can easily be transported from one place to another. On the other hand, transportation of the gaseous fuel is costly and can even cause fire hazards. So, compared to three types of fuels, that is solid, liquid, and gaseous forms, transportation, storage, and handling of gaseous fuels is costly and also difficult because it is highly prone to fire hazards compared to the fuels which are in liquid form or solid form. Then combustion should be easily controllable. That is, combustion of the fuel should be easy to start or stop when required. That means we should have control over the combustion of the fuel. Means whenever we want to start, we must be in a position to start the combustion or the burning process, or when it need to be stopped, we must be in a position to stop it. That type of fuel should be used. Next, 10th point, should not undergo spontaneous combustion. Spontaneous ignition can cause fire hazard. So, the fuel that need to be used should not undergo spontaneous combustion. That is, automatically it should not get fired. Okay, and as and when we need to combust or burn, then only it should start burning. It itself should not start burning. Okay, then 11th point, storage cost in bulk should be low. That is, storage should be low. It is from the economic point of view. Then 12th point, should burn in air with efficiency without much smoke. An ideal fuel is one which should burn efficiently and without producing much of smoke. Because if it produces more smoke, it results in the pollution. 13th and the last point, in case of solid fuels, the size should be uniform so that combustion is regular. So the size of the units of fuel, say for example coal or coke or peat, like that even wood, the size of the units should be uniform so that while burning you can get the uniform combustion or the heat. If it is of various sizes, then it is difficult to get the uniform combustion. Okay, so then we will see what is petroleum. So petroleum or crude oil, otherwise known as crude oil. Here petro means rock, oleum means oil. That means it is produced from a hard rocky substances beneath the earth's surface. It is a dark greenish brown in color, viscous oil found deep in the earth crust. That means it is originated in the deeper layers of the earth crust. As we already told, It is originated from the fossil rocks. Fossils we already discussed that these are the plant and animal materials which were buried deep in the earth some millions of years ago. When they are subjected to high pressures and high temperatures, they become fossil rocks or fossils. From that, this crude oil or petroleum is being extracted. It is composed mainly of various hydrocarbons. This type of crude oils contain lot of hydrocarbons like straight chain paraffins, cycloparaffins, or naphthalenes, olefins, and aromatics. These are the various substances that are present in various proportions in the so-called hydrocarbons or the petroleum, together with small amounts of organic compounds. So in addition to this, there will be small amounts of organic compounds containing oxygen, nitrogen and sulfur also. The oil is usually found floating upon a layer of brine and has a layer of gas on top of it. Generally in the seashore areas, this petroleum will be drilled from the ground, from the deeper layers of the earth. So, generally this petroleum is found over floating. It is like a oil, it is floating upon a layer of brine solution. That means, see, in the offshore area, seabeds, lot of brine solution, salt solution will be there because entire sea or the oceans will have a salt in them. So, the so-called petroleum or crude oil, when you drill deep into the seabed or ocean bed, we will find this product or the petroleum floating on the brine salt solution and has a layer of gas on the top of it. On the top of it, there will be a layer of gas also. The average composition of the crude petroleum is carbon 79.5 to 87%. Roughly we can say 80%. Carbon will be there. 11.5 to 14.8. So suppose you can take it as 15%, that will be hydrogen. Then sulfur 0.1 to 3.5, nitrogen and oxygen 0.1 to 0.5. Like this, the crude petroleum will have its components. Then classification of the petroleum. The chemical nature of the crude petroleum varies with the part of the world in which it is found. There appears, however, to be three principal varieties. So, this so-called petroleum and its components vary from place to place. Then there are three principal varieties of petroleum. One is paraffin-based type. Crude is mainly composed of saturated hydrocarbons from CH4 to CH, C35, H72. These are the chemical formulas for the substances that are present in the crude oil. That is CH4 to C35 and H72. That means in the given petroleum, one atom of carbon and four atoms of hydrogen. This is the substance, and to C35 to H72. These are the hydrocarbons. So this is the range of the substances that are present here, and a little of the naphthalenes and aromatics. The hydrocarbons from C18 to H38 to C35 H72 are semi-solids. When the hydrocarbons are having this type of formulae, then they will be semi-solid in nature and they are called as waxes. Okay, then asphaltic base type crude contains mainly cycloparaffins or naphthalenes with a smaller amount of paraffins and aromatic hydrocarbons. Mixed base type crude contains both paraffinic and asphaltic hydrocarbons and are generally rich in semi-solid waxes. Then, origin of petroleum. According to modern theory, petroleum has resulted from the partial decomposition of marine animals and vegetable organisms of prehistoric forests. So, as we already discussed, the plant parts and animal parts got decomposed after getting buried deep in the earth at a deeper layers. That is, these were present in the prehistoric forest. That is, various vegetative matters or the plants and various types of marine animals and maybe land animals as well. When they are buried deep in the deeper layers of the earth and are subjected to anaerobic reactions under great pressure and temperatures, they got converted into fossil fuels. Out of them only these petroleum products are originated. So change in the earth like volcanoes etc. buried these materials underground where they have been subjected to intense pressure and heat during the ages of time. This is what we explained up to now. The conversion of these materials into various hydrocarbons has been going on either under the influence of radioactive substances like uranium or by the bacterial decomposition under an anaerobic and strongly reducing conditions and temperatures and air pressures. I think everything what is there here we have discussed. This type of buried plant and animal materials under anaerobic conditions, maybe with the influence of certain radioactive materials or with the activities of bacteria under anaerobic conditions or reducing conditions under high pressures and temperatures got converted into this type of fossil fuels. So, three most important liquid fuels derived from petroleum are given here. So, out of this petroleum raw material, three types of petroleum products are derived. They are number one, gasoline or petrol. So, from the petrol, either gasoline or a petrol is obtained between 40 to 120 degrees centigrade. So, when the petroleum raw material is refined at subjecting it to various degrees of temperatures, that is something like a fractional distillation. Various fractions of the petroleum raw material will get separated and they will get collected and named differently and they used for different purposes. For example, in the refinery or the distillation process, the petrol is the product, petrol or the gasoline is the product which we can obtain between 40 to 120 degrees centigrade and is a mixture of hydrocarbons such as C5H12, that is pentane, to C8H18, that is octane. So this type of petrol or gasoline is a mixture of hydrocarbons, various hydrocarbons, starting from pentane C5H12 to octane C8H18. Its approximate composition. So this petrol or gasoline contains 84% of carbon, 15% of hydrogen, nitrogen and sulfur and oxygen all put together around 1%. These are the approximate values. So its calorific value is about 11,250 kilocalories per kg of the material, that is per kg of petrol or gasoline. It is highly volatile, inflammable, and used as a fuel for internal combustion engines of automobile industry and aeroplanes. So the so-called gasoline is used in aeroplanes as a fuel. The petrol is used as a fuel in automobile industries, especially for the automobiles where internal combustion engines are there. This petrol is used as a fuel. Then comes the second one, kerosene oil. It is a fraction obtained between 180 to 2500 degrees centigrade. We told you that petroleum oil is subjected to various degrees of centigrade while refining it. At this temperature, that is 182 degrees, we will get the mixture of hydrocarbons such as C10 to H22, that is decane, to C16 to H34 hexadecane. This is known as kerosene. Its approximate composition is carbon 84%, like your petrol, hydrogen 16, a little more, with less than 0.1% sulfur. Its specific gravity is 0.75 to 0.85. Its calorific value is 11,100 kilocalories. Due to a high boiling point range, kerosene does not vaporize easily. In comparison with petrol, what is the significant difference is petrol, due to its low boiling point, it will get easily vaporized. We can see petrol vapors in the petrol pumps during summer season. That means petrol is easily vaporized. Whereas kerosene has got a high boiling point and therefore we cannot find vaporization so easily. It is used as a domestic fuel in house. So it is a well-known fact that kerosene used as a fuel by the poor people. And of course, as a jet engine fuel also is used for making the oil gas. Also, kerosene is used. Okay. Then diesel oil is a fraction obtained between 250 to 320 degrees centigrade, and it is a mixture of C15 H32 to C18 H38 hydrocarbons. Its density is 0.86 to 0.95. Its calorific value is 11,000 kilocalories per kg. It is used as a diesel engine fuel. So diesel is used in diesel engines. Then LPG as a gas fuel. That is, LPG means liquefied petroleum gas, or it is also known as bottled gas, or refinery gas, is obtained as a byproduct during the crackling of heavy oils or from natural gases. So when natural gas is subjected to crackling or heavy oils are subjected to crackling process, this LPG is produced. LPG is dehydrated, that means water or moisture present will be removed. Desulfurized, that is sulfur is also removed. And traces of odorous organic sulfides that are called mercaptans are added to give warning of a leak. Actually, to this LPG, certain odor smells are added artificially. They are known as mercaptans. This addition of odorous substances is to warn while if it is leaking. That means if it is originally it is smellless. When these odorous substances are added, it acquires certain pungent smell. When this LPG is leaking, because of this smell, we can identify that the gas is leaking. Okay. So LPG supplied under pressure in containers under the trade name like Indian, Bharat gas, etc. Its calorific value is 27,800 kilocalories, very high calorific value. Okay, these LPGs are actually transported uh, in the name of Indian gas, Bharat gas, etc., and mostly used for domestic purposes. The main constituent of LPG are N-butane, isobutane, butylene, propane, with little or no propylene and ethane. Okay, these are next uses. The largest use of LPG at present is domestic fuel. It is also everybody's knowledge that LPG mainly used for domestic fuel for cooking purposes. And of course, it is also used in as a industrial fuel. However, there is an increase in trend to use LPG as a motor fuel also. Nowadays, in automobile industries also, people are converting petrol or diesel engines into LPG running engines. So this is also usage as a motor fuel are also picking up nowadays. In addition to domestic and industrial usage. Then natural gas. Natural gas generally associated with petroleum deposits. Wherever petroleum deposits are there, the natural gas is also available there. It is obtained from the wells dug in the oil bearing region. In the oil bearing region, when the bores are drilled or the wells are drilled, the natural gas is also available in those areas. When natural gas occurs along with petroleum in oil wells, it is called as wet gas. When this type of natural gas is available in the oil wells, where there is a petrol, then they are called it as wet gas. The wet gas is treated to remove propane, propene, butane, and butane, which are used as LPG. On the other hand, when the gas is associated with crude oil, it is called as dry gas. So, in the same oil wells, when this gas is found near crude oil, it is called as dry gas. The calorific value is 12,000 to 14,000 kilocalories per meter cube. Okay. Then uses. It is an excellent domestic fuel and can be conveyed over very large distances in pipes. This so-called natural gas is very good fuel used in domestic purpose, and the advantage here is this natural gas is conveyed over a very large extent, very large distances by using pipelines. అంటే పైప్లైన్ వేసి గ్యాస్ను ఒక ప్రాంతం నుండి ఇంకొక ప్రాంతానికి ట్రాన్స్పోర్ట్ చేయకూడదు. అంటే వెహికల్స్ కానీ ఇట్లా గ్రౌండ్ మీద ట్రైన్స్ వాడకుండా పైప్ లైన్ ద్వారా దీన్ని ట్రాన్స్పోర్ట్ చేస్తారు. ఆర్ ఇట్ కెన్ బి కన్వేడ్ నాట్ ట్రాన్స్పోర్ట్. It is also used as a raw material for manufacturing of carbon black, a filler for rubber, and hydrogen used in ammonia synthesis. Actually, this type of natural gas is used as a raw material in the manufacturing carbon black. Carbon black is a substance which is used as a filler in the rubber industry, and it is also used in producing hydrogen also. This hydrogen is used in the manufacturing of ammonia, which in turn is used for various industrial purposes, including manufacturing of agricultural fertilizers. Then coal gas. Coal gas is obtained when the coal is carbonized or heated in the absence of air at about 1300 degrees centigrade in either coke oven or gas making retorts. So coal oil means coal gas. What is known as a coal gas? It is nothing but a gas obtained by burning the coal anaerobically. That is, in the absence of air, at a very high temperature of 1300 degrees centigrade. Then this coal get carbonized, and what we get is a coal gas. Coal is fed in closed silica retorts, which are then heated to about 13 degrees centigrade. That is by burning producer gas and air mixture. So even by burning producer gas also, we will get a coal gas. So the simple formula or the equation here is coal is there and it is subjected to 13 degrees centigrade temperature in the absence of air, that is anaerobic conditions. What you get is a coke plus coke oven gas. Residue in retorts is coke. Then coal gas is a colorless gas having a characteristic odor. It is lighter than air and burns with a long smoky flame. So coal gas burns with a smoky flame. Its calorific value is 4,900 kilocalories per meter cube. That means coal gas has got less calorific value compared to the others. So with this, the lesson that deals with fuels is concluded. Thank you.